Testing 1, 2, 3. Hopefully this works. Actually, I just think the YouTube streaming page bugged out on me, but I think the stream is fine. Refreshing. Why can't I see my... Oh, okay, now it's coming up. Yeah, cool. Yeah. So I was going to work on a PCB this week, and then I ended up getting a lot of feedback on our first upstream patch submission to bring up Linux on the Apple Silicon platform. So I figured, why not look at that today and see how far I can get into cleaning this up for V2. So I actually just looked up a little bug. I realized the serial port was kind of not working. It was... the debug mode worked, and then when it switched to the real driver, it stopped working. But then the shell worked, which told me that the normals... Like, there's actually 3 ways of using this serial port on Linux. The debug earlycon driver, the console path for the serial port device, which is different from the read-write on the device that you use from userland. And so the console path wasn't working, which told me something about that was broken when the driver was getting loaded. And it was breaking the debug path too, and it was just really dumb. It was just this. Oh, I already committed it. But anyway, yeah, we're SMP. We got all 8 penguins now. Yeah, that bug was just this little dumb thing. So it turns out the default serial port setting actually has the fast transmit enabled, because even though that gets enabled when you open the serial port, the console needs to use that before that happens. And that's a different code path. So it was just this define that was wrong. And that explained... I didn't understand it when I saw this one. It's like, why is it enabling TX before it runs the TX enable function? It's because it prints console stuff without calling the TX enable function. So that's done, and now it works fine. So yeah, that fixed. Okay, so now we have a kernel. I applied a little bit of the feedback, but not much so far into this tree. So it's almost exactly as how I submitted it. So I don't know how much of this you'll be able to see because the font size is kind of small. I can zoom in the message display at least. Maybe hide this a little bit. So you don't even need to see the screen. Just to see that it works is enough. Yeah, so I got 118 messages minus my 18 patch. So 100 messages of feedback, including my replies on the kernel mailing list. You probably can't see the list, but hopefully you can read the messages. So this is what I submitted, the 18 patch set. It begins with this cover letter. And I mean, this wasn't going to be merged as is, of course. It's just the first attempt. But all the feedback I got should be enough to get me to a point where I'm a lot closer to this getting merged. So if I get lucky and I can address all of this feedback, there will be a V2. And then if nothing major comes up, we could even get to this being upstreamed on like a V3 or V4. It's definitely not going to get upstreamed on a V2. There's maybe more nits for sure. But if all the big things are done by V2, then hopefully a couple rounds of fixing little nits will get it into shape. Or we might run into something big and then it's off the drawing board. So yeah, I sent that in, and what I'm going to do now is go patch by patch, take notes, and I'm actually going to make a notes file here. And see how far we can get. I'm actually going to rebuild the whole submission tree because it's easier than rebasing everything every time. So first of all, so this was the old Apple PowerPC machines used AAPL, the stock ticker symbol in all caps, as the vendor ID. Originally, I kept that just for traditional reasons, I guess, but people like Apple in lowercase letter better. So because that's very unique, what I can do probably is... So first of all, I'm going to check out a temporary branch from the base. Actually, first I'm gonna do it this way because this is probably gonna be easiest. So I think, yeah. So I'm gonna re-export all the patches. And that one is 17 now because I think I changed something. Not sure if I merged something back in or got rid of something. Let me just double check to see what happened here. Okay, config 5 is TTY, 8 is CPU feature, yeah. 17 is the Mac Mini. 16 API, 13. Oh, is the IO remap thing gone? No, it's 11 and 12. 12 and 13 before that. Oh, the require FIQ support thing was gone because that's moved? I'm not sure, but we'll redo it anyway. Yeah, so I'm going to just do this on the patches. And then... Hold on. There you go. I think I have an 0018 in here that should not be in there. Oh yeah, I got all the old, damn it. I need to get rid of all this stuff. Wait, what just happened? How did I end up with same date? Sorry, hold on, I'm just cleaning this up again. Slightly confused here. Rig, format patch base. Okay, that makes... What? Okay, now it's fine, yeah. This should be on base. Yep. Apply everything. And that was 0. Yes, fine. So that's just a little APL cleanup, and that should tick off the first thing. So I should probably tag these emails as watched. Add some kind of tag here. 0, 1, yeah, so I'm gonna use the import. Could just use red things, but I'm gonna make a new tag actually, call it done. Make it a bit easier to handle. That's 7, cool. So if I look at this now, there should be, oh, that's clear. And now what I'm gonna do now is actually, just use a shorter name for this. Okay, cool. And yeah, all of this should be Apple. Yeah, so that's one change I could automate. So for my patches, I don't need to do anything. And then the reply for that is just use Apple. So we're cool with that. And this is just more discussion on that same story. So that's done. There was no feedback on this one, so I think we're cool here. Bindings for ARM platforms. I need to get rid of this because we're not going to use that anymore. Actually, let me just re-index this whole... No, I don't want to do that, actually. What did I just call that? IBRef. Cool. So the first patches are done. Just cherry pick these things. Do that one. Do this one. And this one needs changes. So this goes away because we're going to do that. That was basically a hack that we don't need anymore. So again, nothing interesting there other than that. And then config arch apple. So this is actually going to get moved later in the tree. So I'm going to leave that for later because we're reordering things so that I can introduce, basically merge two things there. So the UARTs. There's going to be a bunch of changes here. So first, cherry pick that and then start changing things. The tricky bit is that I actually want to test this. So even though I'm doing this in this tree here, what I should probably do is check out the reference tree. Oh, I forgot to amend the other one, sorry. Just fix this real quick. That patch in the right place. So what I probably want to do is temporarily... Yeah. Especially for the serial driver, I want to do this the other way around. So what I'm going to do is leave this aside for a second. Go back here, make sure this boots, which it should. And make a note of something else to do a bit later. The device tree names ARM platform removed. Because that goes with this one here. And this is going to take a while to build, so while that happens, let's start looking at the Samsung T2i. So the story here was, I'm going to split this into two patches. One that just refactors the existing Samsung code, and one that actually adds the Apple support. That's going to be easiest to do once I add support for both, and then just kind of separately recommit the changes. So this is going away, first of all, that hack. The not in IRQ thing, what we're going to do is txtars here. That function is actually the interrupt controller function, and so the interrupt handler function, sorry. And so what I'm going to do is call that txrq. And so the thing was that we need to call this function we need to call this when transmitting, when starting a transmit, because is RQ used anywhere? No, it's not. So we don't need that. Is ID used anywhere? Yeah, that's just the R port thing. So we can do it that way. Hold on. Yeah, the vendor prefix patch needs its comment. Yeah, I'll go through all the comments anyway. Later. I wanted to get the code part first. But I'll do a review. So let me make a note to do that later. So what I was saying is we need to call this function independently of the lock. So, sorry, not rxtx, here. So we need to load port, and then that should be... Does this use our port anywhere? It does. Just pass that in here. Then rxchars just for consistency, we're going to call it rxirq. Then in txirq, basically all it has to do is call that. That should be fine. And there's no IRQ usage here, and this goes away. Yep, something like that. Make sure this still builds. Yep, nope. Did I break? Oh yeah, we don't need this anymore. This just goes to our port. And then the prototype. Actually, should just be in here. And we don't return any IRQs, so honestly, that out thing can just go and be a return. And flags is gone, which also means this needs to go here. Cool. So while I mess with it further, wait, it didn't boot. Why did that not boot? Interesting, I broke something. A lot, because nothing booted. Oh yeah, because ARM platform is not set. No, it should be. Hold on. Which branch am I on? That should be fine. Let's see what broke. As long as that's still on here, it should work. Everyone asks about my text editor. It's not even an IDE, it's just Kate, which is a text editor. Just a fancy one. Yeah, I broke something, obviously. I wonder what happened. Hold on. It's not the changes I just made to the driver, because that isn't even used at this point. So hold on. Am I using the right DTS? Oh, I'm not. That's why. That's why. It's the Apple thing. Needs to be using the kernel tree one. That should work now. Because I just renamed this to Apple, and that matters for something which is going away later, but not now. So that gets checked later. This one, I did fix these kernel test robot things. That's gone anyway. That's more kernel. I like how the robot says, "I love your patch. Yet something to improve. Build failure." All right. So yeah. So I'll do this later once the whole thing is ready. That's what I just did. No, sorry, that's not what I just did. This is not something we can't do that. But this is done. I already explained this. The locking is already done when I'm not in the interrupt. Yeah, this needs doing. Okay, cool, this works. And I got all the logs, and yeah, fine. And input works, right? Just to make sure that's the wrong thing. Yeah. Cool. So, yes. So the handlers, this is something that needs to be fixed in both the old ones, but basically... What are the constants for this? IRQ none. So the idea is that, I mean, if there are errors or something, then that's a different story. But basically, if one is none, then the other one takes preference. So if either IRQ is handled, then we consider it IRQ handled. Though, honestly, given the other code, this doesn't actually matter because this always returns IRQ handled. So it's kind of pointless. But it does make sense in case this gets changed. Honestly, this should be returning, like... Yeah. The main difference is RX. Does that one at least do it right? It does RX, PIO. It always returns... Yeah, it always returns handled. That's a little bit sad. Yeah, so the main benefit of doing it this way is that if at least if neither of them status bits are set, then it will return IRQ none. So actually, because they always return handled anyway, we don't need that whole thing. Let's just do it like this. And if someone asks, it's like, well, the functions always return handled anyway, so the logic is going to be the same. So really just change this, make it IRQ none, and that's good enough. We don't need the shared in the Apple version, which is this one. And the new port type thing is going away. This is one of the big ones. I actually asked Greg KH. For those who don't know, he's a very well-known kernel dev, and yeah, he said, "Don't do that." For some reason, like the serial port and TTY code in Linux is one of the oldest things it has, understandably, and there are some terrible patterns like exporting what serial port type you have in a kernel header file, which is complete nonsense. And yeah, like I added a new one because all the others were there, and that was how all the other Samsung variants did it, but that doesn't make any sense. So actually, this is going in UAPI and serial. Where is that thing? I'm gonna find the file. This thing. So this is not happening, and that's going to require an interesting refactor of Samsung TTY, which I'm going to do now. So I had this IRQ type, and I'm going to call it port type. I'm going to call it type S3C24XX. And type Apple is 5L. Do I have a link to the patches on the LKML? If you look at our Asahi Linux Twitter, I believe I linked it in there. Yep. It's the latest actual tweet in there, so you can find it that way. So the interesting thing is we're going to need the type in here, which means this is going to go above this, so we can actually use an enum. And this type, I think, is the port type, and we don't really need that. I don't know. Let's see. Info type. Yeah, this is the 2-port. I'm going to get rid of that function anyway. Yeah, so this returns from that. I don't think we care about separating these out anyway. So that can just go on our type. And then the actual port type just gets set to info type. Yes, I'm going to just call this port type. And then in the infos here, and for that one, well, he said just to use port 8250. Greg says use port 8250, then port 8250 it is. Actually, well, since type is more important than port type anyway, Let's do it like this. That was the last one. Okay. That will be checking port type. Port type info, port type. That's mostly there. And so then, where else is this port stuff done? So this does check on type. And actually this will go away because we're basically doing the same thing anyway. So let's see where else we have that. Case sensitivity. I don't think we care about those strings being everything anyway. Yeah, I think that's basically the only place it's used anyway. If equals, yeah, type equals 4xx. Wait, 2440. That's one only different one. You can mask. Wait, that's only in clock cell mask though. It just adds this for clock cell mask. Is there any? Ah, I see. So this gets set for. I see. Okay. So we need a Yukon mask too. Is this used anywhere else? No, just here. And the maintainer for this mentioned specifically how to do this. Yeah, 2464. That's what I sent. Christoph said. Yeah, this one. We'll take care of that in a second, but yeah, Yukon mask. That's what I said, so. And that was only doing this, so. And I think that can just be left alone. for 2440. You know, aren't we resetting this anyway? Do we need this? Reset port resets that. Because we already have a Yukon default setting, so where is that applied? Maybe that is all useless anyway. Hold on. Is that in here? Yeah. Konbaba. Where it? Oh, wait. No, it just ORs. Oh, okay. So the Yukon defaults get ORed in with Yukon, but those only set bits, not clear bits. That's why. Speaking of, why do we have two structures anyway? Why is there a UART info and a UART default? It's like, why do we even have two things here? It's kind of weird. But whatever. And judging by has diff slot being 0 here, we don't actually need to care about zeros, which, I mean, obviously missing things are initialized to 0 anyways, so that should be fine. And in that case, this is the only place we need. And you can just do this. Oh, actually, hold on. Clock cell mask. Hold on, what did that code do in a second? Oh, I see. That keeps that bit. Ah, I see what it's doing. Okay. That makes more sense. So clock cell mask and Yukon mask, it's keeping that bit. That makes sense. Okay. 24. Is that used anywhere else? No. So that's why. It just keeps some divider setting from the firmware so it doesn't touch it. That's fine. We can deal with that. Might be useful for Apple later when we get to clocks. Okay, this makes sense then. So that should be fine then. Let's see how bad I broke the build so far. Pretty bad. Yeah, so we need the RQ Apple stuff that needs fixing, so it's not RQ type, so every time this happens, we need to do port, should be our port, info type. And then in that case, we do RQ Apple base at type Apple S5L. And we do IRQ S3C 640 type. And then I'm just going to search for discrete. And actually, I think he said that I really should be doing it like... I think he's going to be fine with me just doing it like this. It could be a switch with a default or something, but I think for now this is fine. Cool. Yeah, this is not handled. And then this is going to go away anyway. That's part of the feedback that I got. The serial startup, serial ops. Where is that? Here. It'd be really nice to like be able to inherit these things, but and the difference here is the ops here, startups, these go away. And this one. Let's call it S5L. Cool. And then the other one was the interrupts, but those get handled here anyway. And yeah. Actually, I just realized that this is totally terrible. The way this was working... was this copying them? But I just realized where that happened. Oh, yeah. Oh, that... Yeah, okay, I just realized, like, the original code there was completely horrible. I mean, it would work, because you wouldn't have more than one such serial port in the same device normally, but... Ew, no, that was definitely really wrong in the original. I just realized that it was overriding a function in global data, not in per port data. That's a no-no. Yeah. That's one thing, right? Is like, you're writing things and then you see a code pattern, and the obvious thing to do is just follow the same exact pattern. But sometimes that pattern is terrible and shouldn't have been there in the first place. And so then you end up running into things in the original code that need fixing because they're not up to standard. All right, let's build that again. Let's see, we got some other enum stuff going on there. Yeah, so this one. Nothing to do in this one. I'm going to rename these 5L anyway. Yeah, it's kind of long, though. Nah. Well, for consistency with the port name anyway, we'll go with that. That's easy enough to change it later if we decide that it's a bad idea. And keep those aligned. Actually, it's fine to do it like this. Cool, so we got that. And then the other enum, this one. So one thing I actually need to do here is I need to enable PM sleep, because there's a part of this code that doesn't get built except when sleeping is enabled. And this is I thought we could go there with this one. Oh, because that gets yeah. Yeah, cool. Well, that's actually a useful one. That'll be fun to experiment with later anyway. But not right now. For now, this is going to rebuild everything now. But that might give me some build errors too. And actually, this makes more sense like this, to be honest. It's more uniform than trying to do it in here. And then this goes down. Actually, does this even get set in any of the others? Yeah, it does on startup. Honestly, it doesn't get used much. It just does tx enable tx claim. I mean, why is even tx? Why is tx claimed a thing anyway? That only gets used there, and then it gets set to 1, but nothing uses that. Then tx enabled just does the stop. Sets it to 1. Yeah, that's working as usual. And then tx claimed Just get set to 1 there. That's all. That's not really useful, is it? And these are just the ops, start up and shut down, and then shut down. This is kind of silly, to be honest. Yeah, you know what? I'm going to refactor this. We already have separate ops anyway. And it makes sense to have startup and shutdown be separate ops. So get rid of all of that. I think I just did something stupid. Hold on. 64 startup, Apple startup. Yeah, just did something dumb, didn't I? No, this is startup. That's fine. Hey, no, hold on. 60. Hold on, just did something silly here. Yeah, okay. Just I accidentally renamed that. That's fine. And then shut down. Yeah. And then for 64, we just do this. And there's no TX claimed anyway, so... Because it's all done anyway, so what's the point? Heck, we don't even need those TX claimed. Nothing uses that. It's only used for, like, the error path, if that, so... What's the point of that? Yeah. Yeah, so for the normal case, we just do that. For this one, we just do enabled, and then for Apple, it's the same thing with different shutdown code. I think this makes more sense. All right. We're running into the... Ooh, barely. Should probably break that. Ooh, lots of junk. Actually, just do this. Get them in the header file too. Oh, we're getting there? Cool. And these are not needed. And these are also like completely different. So why are we... Oh, it's PM ops. Ah. Can we do that also with proper ops? Serial that goes through this thing, ports. And this is all ugly anyway. It's like the autoconf stuff. Wait, where is that used? Oh, is this these static ones? Ah. Yeah, and probe. Oh, this is gonna be annoying. It registers drivers. I need to this. I'm not going to claim to understand how the serial port drivers work, but they clearly work in some horrible ways that are not how normal drivers are supposed to work. Probe index. Okay, so those are these. So that's a global? Oh yeah, it is. EU. Yeah, it registers driver. And then add one port. Oh, okay, here's where it adds the UART port. And then where are the PMOs done? Oh, that's just in the platform driver. Yeah, I guess it's possibly not worth doing that. It's gonna be a bit annoying to clean this up. But at least I need to set the ops on the other one, so... What was that thing? Let's go with the probe. Yeah, so at least this is meant to change, so... Our port is one of these things. Yeah, okay. Yeah, that's kind of sad, but okay. So... In probe, what we need to do is... info type. S6. Oh, what was the thing? $64. Okay, yeah. That. Something like that. The people asking about storage, like the reason why I'm... So, okay. My goal is to not to make Linux work on Apple Silicon. My goal is to make Linux work in upstream Linux on Apple Silicon. And that means my priority is not getting all the drivers working. My priority is getting all the drivers working in a way that I'm not wasting my time by then having to redo things when the way I'm doing things is not a way that makes sense with upstream. And so for that reason, I'm focusing on getting the basic Apple Silicon support upstream, which means what we have now, serial port, SMP, and like interrupts and things like that. Because that base, if it moves, it can change the way a lot of things work on top of that. And so once this patch is done, which should be like today, tomorrow, and sent, and if I don't have any sort of game-breaking feedback about it, then I'm going to start working on all the other devices. But right now, like, I want to get this to the point where it's basically done in a way that upstream is happy with, so that I don't have to redo things later if it turns out it wasn't done the right way. So, like, unlike sort of previous projects where the primary goal was getting as much hardware working as fast as possible because we were just trying to basically, get something we could show off, like, Linux on consoles or things like that. This is this has a long-term timeline, right? So it's less about getting all the drivers in first and more about getting to a better point on the longer term. So like the time I'm spending now polishing this very beginning, even though it's not like flashy because all I got to show is like, this frame buffer console at this point, means that in the future, we're going to get to having all the useful bits upstreamed much faster. And there's also another big benefit, which means that by upstreaming this first, I'm getting upstream Linux developers interested. So not only am I doing this project, like I'm sort of leading this project myself, and not only am I involving people who are interested in Apple Silicon from the beginning or who know me, but now I have Linux kernel devs with, like years or decades of experience in our IRC channel because I sent it upstream. And that's very valuable, right? So that's kind of why I'm playing this out this way, right? Like people are asking why, okay, so like, are we getting storage working? What drivers are getting working? And the answer is I haven't looked at any of that yet, because it would lead to flashier short-term results and slower long-term results. And so, like, I can't promise any timelines, but my goal right now, and I will this is sort of a personal milestone thing, is that before the end of the year, I would like to have an accelerated GPU desktop running with all the basic features. Maybe not the best power management and things like that. We'll see, but like, at least I would like to be able to say, look, we have a desktop running. We can have a compositor, and like the screen, like display driver works, and we can rotate it and all those things, and like sort of a not a proof of concept anymore, but sort of serious. Okay, this is possibly rough around the corners, but basically everything works, right? That's kind of my personal goal. I don't know if we'll get there. I can't promise anything, but like looking towards that, a big part of that is doing it right? And that means talking to a lot of people to figure out what the right way of doing it is, because and the evidence for that is this thing, right? Is the 100 messages that were exchanged for this simple, just to get the 8 penguins on the screen up. There was 100 messages of discussion on the mailing list. But that is all very valuable. So it makes more sense to have these 100 messages now and get this all really nicely done now, rather than for me to say, well, I got SMP working, so I'm going to go off and get NVMe working, and then USB working, and then SPI and R2C, and like all these other drivers, which I could, but then I would have to spend, months rewriting a lot of things and remaking a lot of things. I mean, you saw this, like you saw I'm doing here, right? Like this was a stupid patch to the Samsung driver. I'm still doing a major refactor because it turns out that, the original code was a little bit messy, and the way I did it made it a little bit messier. And so it's better to, get rid of technical debt and clean things up and improve the original driver before I add my things to it, which is what I'm doing now. And it's not that bad, I'm almost done. But it's these things, right? And a lot of the thing about Linux is that, it's a big community of developers writing it. And so you can, it's very easy to go into the Linux kernel and say, well, I'm going to add a patch to fix this problem. Because, and I've done that a number of times. I've sent, I don't even think I ever sent a V2 to the Linux kernel before, because all my previous contributions that I personally upstreamed were fixes for drivers, right? It was like, work around this problem, add this quirk for this device. And the way of doing it was obvious enough that every time the maintainer just said, cool. Or, not sure, but it looks fine enough, so cool, right? And that's fine when you're just making little changes. But in this case, the M1 is a new SoC, which means a lot of changes to begin with, and a particularly weird one at that, which means we also need to engineer bespoke new mechanisms that don't exist in Linux right now to deal with some things the M1 does that no other chip does to date. And that's part of this patch set. I'm going to get there once I get done with the serial stuff. Yeah, I'm not saying you're crazy. It's just that you're not the only person who is asking, is this working? Is that working? I'm not blaming you or anything. I'm just explaining why it might look like this looks the same as last week, and but the impression that people have of the amount of work required to do things is quite different from the actual distribution of that work, right? Like, for example, getting the screen to work, getting the frame buffer to work was literally 0 lines of code. Because Linux already has a dumb driver that can put up a screen like that. So all I had to do was instantiate it, like literally just 5 lines of the device tree, 0 patches to Linux once the basic CPU stuff was working. And because you have a frame buffer, that means that I could stick like Wayland and Xorg running on a frame buffer in an init ramifest and pull up a graphical Linux, environment, and it would work. And I don't have storage and I don't have a mouse, but I have a serial port, so I could even hack up some kind of remote mouse over serial, and suddenly it's desktop Linux. And like someone will look at that desktop Linux and say, wow, they got a graphical environment working. And it's literally this exact same kernel that I'm running right now, right? Like I could pull up a window manager and a bunch of other things literally with no further changes to Linux right now, but it's pointless, right? It's a demo. It's not the actual way graphics are going to be done when we are, this is running later this year, right? So there's no point in me doing that. And so it's the same with like the other drivers, right? Like you can hack things up in some way. You can make it work some way, right? But instead of making it work some way and then figuring out what is the right way of doing it and possibly redoing that work, I would much rather figure out what the right way of doing it first is. And so the progression basically here is once this patch set is looking, it doesn't mean I'm like doing one thing and then not working on anything else until that's done. It just means that there's less overlap, right? So once this V2 is done, assuming there's no weird showstopper things, I'm going to start working on some of the other drivers. And so another one that needs to happen is I2C. That is actually based on a PA-SEMI I2C driver that already exists in Linux. I already emailed the guy who wrote it, and he said that he can test changes. So we need a significant refactor to that for Apple, because we want to add like interrupt support and things like that the original hardware supported, but the driver no longer does. So it's the same situation as this Samsung driver, right? Adding Apple support to an existing driver. And so the next thing I'll do is that one, because we need that for a lot of things, like the USB ports to work properly and everything. And so I got documentation for the old hardware, so I can try that on the M1 and see how similar Apple's implementation is of that same hardware, and basically implement support for the Apple variant in the driver, and sort of implement that the same thing is going to work on the old hardware if it all looks the same. And then I'll send it to this guy and ask him, okay, can you test this on an Amiga X1000, which is like the platform that people actually use that driver for. And if it works, then we can just submit it, right? And the nice thing is that once we have this core Apple stuff in, all those changes to different drivers aren't single patch sets that get sent to the kernel to 12 people and that get 100 comments. They're individual things, right? So once this core support is in, I can be working on I2C, send it to that guy, and that's, it's a patch to that guy and to the maintainer of that subsystem. And then I can be working on something else and send another patch to someone else. And at that point, it's not a single, we will upstream Linux support for the M1 to the kernel. It's the kernel already supports the bare bones of the M1. And so now we're just adding all the little bits and pieces, and all that can happen in parallel. And in the longer term, that's much more efficient because all the little bits and pieces are happening at the same time. But that is all conditioned on this base being right. And so more specifically, the dependencies that we're going to have after this is the I2C thing is a low-level driver, but that depends on interrupts, which are in here, but possibly also clocks and power gating. And so that will need to happen pretty soon after this patch set, because everything depends on clocks. Once we have clocks and power gating, or at least bare bones support for those, almost everything else can happen in parallel on top of that. Another thing that I'm also working on is delegating as much work as possible to our bootloader, because the less code Linux needs to support the M1, the better. And so, for example, our bootloader is configuring the hardware and the CPUs in ways that work with default Linux code that already exists, and that avoids having to patch Linux to deal with these things. And the nice thing is that not only helps Linux, but we have U-boot in between too. I'm not using U-boot right now, but in the long term, we'll be using U-boot for, obviously, people want to use, like, bootloaders with fancy support for USB and things like that. And so you'll have this chain, right, of like my first stage bootloader mini sort of bridges the Apple weird world to the closest thing we can get to a standard Linux ARM64 world. And then on top of that, we'll have U-boot. And so anything I deal with and I initialize in my mini that is specific to M1 is something U-boot doesn't have to deal with, and it's something the kernel doesn't have to deal with. So it's 2 for 1, right? Because otherwise you have to make both of them deal with it, potentially. So after this is done, actually, the next thing that I'm probably going to look at is I'll look at clocks and power gating, because I need to do that anyway. And Mini will have to gain some support for that, for turning things on for other bootloaders. But also PCI Express and the USB 5. Basically, one of the things that these things need is that they need like a bunch of calibration data loaded into the hardware when you boot. And Apple gives us that calibration data, and we need to apply it. And if I can do that once in Mini and never have to deal with it again, then that's the best possible case. And the only question there is whether that needs to be done again when we resume from sleep. But how we're going to handle sleep is already a open question, because I believe that if we do a full system sleep, then we actually need to call into my bootloader again for technical reasons of how Apple implemented protections in the hardware. And if that's the case, then because it's going to jump into my bootloader anyway, and we need some kind of interface to get from that to Linux anyway, then I might as well just do the same unit in the bootloader anyway. And again, best of all worlds, right? We need to implement if we need to implement a bespoke mechanism for going from full system sleep back to Linux through my bootloader, which seems to be the case. And the only question there is whether we are ever going to go through full system sleep or not. But if we do, and if that all matches that's the same case as when we need to reinitialize like all of these calibration parameters, then it makes sense to do it in Mini. And then again, U-boot on Linux don't have to care about any of that. That's the device tunables, not the CPU tunables. That's already done in Mini anyway. But the PCI Express and USB and other tunables, like Apple puts a bunch of those blobs in the device tree, and so those need to be applied. And the question is, how many times do they have to be applied? But if they only need to be applied after a full system wake up, which, as I understand it, has to go through Mini anyway. And the reason for that is that the sort of reset vector for the boot CPU is locked down by a boot. So I need to leave some code in memory at the original Mini load address to handle that anyway. And what we don't have right now, by the way, is a way for that to jump back to Linux, because normally Linux on systems that do that kind of sleep will use either ACP or PSCI. And I'm talking with the kernel devs about this. We're having stories of re-implementing parts of PSCI over UEFI or over like this. There's a whole bunch of discussions to be had there. But once that all makes sense, I think it's quite likely that we can avoid the entire tunables thing in Linux and U-boot. So yeah, we're talking about a lot of these things, and that's going to save time in the long run over just doing something now that works and then cleaning it up later. Yeah, Mini already parses the Apple device trees. Mini already takes the Apple device trees and transforms information from them to the Linux device tree. We're not converting Apple device trees to Linux device trees. We're taking things that vary from Apple device trees and inserting them into Linux device trees. So specifically, what my rule for Mini is that Mini doesn't use Linux device trees for anything. Mini everything it needs, it reads from the Apple device tree. And so the idea is that, in theory, we should be able to boot Mini on any even future... I mean, to some extent, there will be things that have to be added. But basically, you should be able to take this existing Mini and boot it on M2, hypothetically. And probably only the CPU tunables would have to be added. And it would probably work without that initially anyway, because the CPUs aren't that broken without the tunables. And so that makes it easier to support newer devices by having a base that works. And then we will have Linux device trees for those devices that we will be writing. And then Mini's job is to take some of that Apple device tree information and move it over to Linux. So basically, this is the Apple device tree support. That's already done. The format is all complete. And if you go to, not everything is using it yet, but if you go to things like smp.c, when I boot up the other CPUs, you'll see that I use the Apple device tree information to figure out how to access the CPUs. So unless they change the hardware, this should just work on newer platforms anyway. But then here is where I take stuff from the Apple device tree and insert it into Linux device tree. So in this case, it's just the init RD, and which isn't even in the Apple device tree. But the frame buffer comes from a different structure that Apple gives us, and that gets put into the. So that's why the penguins work, right? This is literally all that is needed to get the penguins work. Is this is it was originally hard coded, but now it's properly done. Configures the frame buffer for Linux, and then the other one is like the memory size, right? That also needs to go in here. Although in this case I don't even use these. I used to use these, and then I stopped doing that. But that also comes from a different structure, the actual usable memory range. And then here for the CPUs, I actually use the real MPIDRs I get from CPUs. So I get the CPU IDs after booting the CPUs and stick that into the Linux device tree. And then the addresses we need to release them. So this is the approach, right? This file will convert anything we need to convert from Apple to Linux, including tunables that we can't apply here. And though most likely, if we get the tunables in here, probably one of the few things that will be going from Apple device tree to Linux device tree is like MAC addresses, because those are in there. But yeah, so that's kind of the approach here. Anyway, back to Serial. Let's see what I broke or didn't break here. This needs a and, doesn't it? Yeah. And yeah, I haven't looked at audio yet. If you want to look into audio, go ahead. You should definitely end up going through like the ASOC framework, but I have no idea how it works. So, cool. We at least got the This is just doing the clock controls. Yeah. And then resume no IRQ. Why is that? Oh, did I eat a comma there? Yeah. Huh? Okay, that was just me pressing keys that I shouldn't have pressed. I think that's fine. Oh, cool, no errors. Okay, let's see if I didn't break it. Bare metal babble. Have I mentioned that I've had that idea in my mind forever? I want the apple to like turn into the intro apple, and you know. Though the question is how would that work? It's the opposite. It's the white and black are switched, right? From the apple to the. So it would have to like crossfade from white to black to white, and then start turning. Unless the switch happens like at the symbol hit of the song. Cool, it works. Okay, so I think this is looking good. So let me review that. Oh, the feedback for this thing. Okay, so that's the kernel test robot. I know I fixed this. That's done. So we can mark that done. That's done. That's the one that talked about Yukon. Yeah, that's done. Okay, so Mark said, yeah, we're going to do the split when we commit everything. We already said that's done. We already said that's covered. That's done. That's done. And the new port type is done. So we can say that's done. V2, yeah, this is just my replies to everything. Like that, and then that's the CC. And get maintainers, V2. Yep. And then Mark said, this is the path. Pick one. Yep. And then this is the thing I sent to Greg. And then Greg said use that, which is exactly what I did. And then recruitable as my message. Yeah, so we are going to do this, but the way, not with IRQs, but the thing. Okay, yeah, what happened here? IRQ type. Well, we're not doing that anyway. I think once we get the patch, I'll do a style check on everything anyway. Unlocked and unlocking wrapper. Yeah, that's what we just did. Apple S5L, I think. Yeah, that's what we called it. And that is fixed. And we already covered that. UAPI, doing that there. Let's report your ops. Yeah. And we already covered this, because those are the same. So we get 3 types. Added the Yukon mask and 3 ops, and those are now const. Cool. And then we got that. And that's my reply. Okay, so that should be all the feedback I got for that. So let's see if I can clean it up into different patches. Maybe do that in here. Yeah, so what I'm going to do is actually but first let me add everything. These are changes since my last thing. I'm going to redo the patching. And I'm going to do it in separate chunks anyway, because that's going to be a lot easier to review. So first, just to make sure we don't kill anything. Cool. And it goes in. Okay, so now we go in here. And then, so what I'm going to do is apply that as a fix-up. And then undo that. Ooh. Did I just break? What? Oh, hold on. Did I just... Was the cherry pick broken? Hold on, I'm a bit confused as to what happened here. Oh, why is it empty? Oh, it's already there. Sorry. That is done. It should be fine. I'm confused. How is the rebase without doing anything breaking? I'm kind of confused here. This works. Oh, origin. Oh, sorry. Base. Wrong. That's why. Wrong thing. Okay. Wrong base for that. Okay. Sorry. Wrong rebase. Yeah. I was doing the wrong release. Okay, so you undo the commit, and then now all that is gone. This is the previous one, and so I can just do that. So yeah, we can just add p things. It's gonna be a bit annoying, but it should be fine. So the first thing I want to do is split the interrupt functions by yeah. First, I'm going to do the IRQ type splits, the ops things. So for the ops splits, let me think about how I want to split these things. Actually, you know what? I'm going to look at everything for a second. So the first thing we need to do is if we do the port thing, yeah, moving the port to type thing makes sense. What just happened here with the double resume? That's weird. Hold on. How did that compile? Because comma operator, I guess? That's weird. Yeah, so has interrupt mask. Yeah, I think we can do that together. And then for the ops, probably doing the ops first makes more sense. Because that's mostly standalone. So let's do the ops first. So in that case, it's basically just the last thing there. Yeah, so startup. So shut down the Riku, and then yeah, this is part of it. So I'm gonna split that. Oh shit, wrong thing. Serial GX chars. Here, split. Okay, so the first thing is split that. Did that change? No, that's different. Yeah, add that. GX in progress 0, and then split that. That's not gonna work. Its patch is gonna be annoying to clean up. Oh no, it's not. Because I can just do this. This is annoying. Our port DMA, it needs a blank line before that. That should work. Yeah. Request IRQ, that's a different thing. And then we don't need that in serial startup. We don't need the new one. We're not doing that yet. We're not doing that yet. Not that yet. And then that gets none of the Apple stuff. And this is in reset port. Yep, so startup is different. Not doing the interrupt mask. And these are the init port. On Pro, instead the ops, but no Apple on this one. Oh, but I need to check the type. I'll do that later. I need to edit that. Restore RQ mask. Don't doing that one. And not doing those. None of that yet. None of that yet. Okay. Yeah, I need to fix that thing. Git stash. And then what was that? Should fail, I think. So we had the type thing, right? Oh wait, I stashed everything. Oh, did I just lose the damn it? Forgot. Yeah, I should have committed that. Stash does not separately save the index, does it? Damn it. Yeah. I thought it used to do that. But I guess it doesn't it? Yeah, the stash. No, it has the index. I thought that's what it did. Oh, what's the... Hold on. There's list. Yeah. Hold on, do I have the index somewhere? Probably not. That's a different thing. Ah, is that what it is? Oh, okay, I see. So it saves the last one. But that was the one I just dropped, didn't I? Damn it. Okay, hold on. I can at least do the other thing now as a patch edit. Okay, so yeah, that... Okay, so yeah, this info type, and should be port. I think that should be fine. Actually, I'll keep this one. Well, it's like default because there's more than one port. This is before the thing gets changed to... Yeah. Actually, you can just do it like that. This is, yeah. Hold on. $24.10, $12.40. 00 is not used, right? Yeah, it's not. That might work. Yep. Okay. I'm just going to copy some of that commit message stuff. Yeah, this is the prefix I need. Mm, 64, was it? Why is it not wrapping? And I believe this should be uppercase. Okay, so in theory, this makes sense, and it should have no functional changes. Checks the interrupt mask. You're not doing that, so it's just free IRQ for those cases. And then it just does the DMA and TX in progress thing. Otherwise, for serial shutdown, it just ignores the RX claim thing, and it just sets TX enabled and mode to 0 and RX enabled to 0. Get rid of the RX claimed and TX claimed thing, and then if I do startup and shutdown for those, gets rid of the override, and then a bit later, so that actually gets done in init port. That should work here, so I just stash everything now and double check that this all makes sense. So init port gets called here, and the ops get changed here, so it's before that, so it's fine. And I think that should be fine. And then just double check that RX claimed is not used anywhere in 64. Yeah, it's only used in shutdown and startup, so. Let's see. Cool, that makes sense. So let's see if it builds. Did it actually build this? Let's make sure I'm actually building it. No, I'm not. Hold on. Oh, hold on. I need that. Yeah. Because this is still using... Yeah. This thing. Because I don't have the Apple stuff in there yet. Ooh, paint control. I don't know what that is, but that's not my fault. I think. Yeah. So basically, I'm refactoring the existing driver first. So instead of because some things were so this driver is very messy to begin with. If I had infinite time, I would go through and do a major cleanup of it. But because we don't have infinite time, what we can do is, while we add things to the driver, try to clean up an equal amount of things so that the end result is better than the previous state instead of worse. And so to that end, the code was originally patching a list of functions depending on which device it was using. That's a terrible idea, because hypothetically you could have somehow a chip that has both types of serial ports, and then it would get very confused. Even though that's probably never going to happen, it's a terrible code pattern. So instead of that, I made a separate structure to have a separate list of functions that is different for that one chip. So this is basically cleanup. This is cleaning up the existing code. And it's cleaning up the existing code so that when I add the Apple one, it's not worse. Okay, what did I break? Okay, this is different. This is actually a different problem with... this is a different problem with this, which I might as well fix also. For my dev ID. Oh no, is this just a... unmet direct dependency installation, or OFGPIO. This is a different problem, but I might as well fix it while I'm here, so... I'm not entirely sure how the kconfig... ping control XNOS depends on all these things. Is it because... I think it just means that... I think we just need this thing in here. Yeah. Yeah, I could submit this as a separate patch though, but let's see. Well, I'm not going to do it now because it doesn't make sense in the same patch set, but I might as well add it. And then we get all these things. And then also needs gpiolib. Yeah, it's in there. Is that actually selected by... Oh, hold on. I think we just need gpiolib. Probably just need that one, actually. Yeah. I think if I just get rid of that, it'll get the right value. Yeah. Okay, cool. Yeah, we just need gpiolib. I don't have to change this. This is that because I'm making changes to the Samsung serial port driver first, before adding Apple support, I need to test that I didn't break anything. And I just found a problem in the Samsung Exynos support, which I had to enable to be able to build the Apple. Sorry, build the serial driver before. So I basically, because I'm changing Samsung code before adding Apple support to Samsung code, I need to test this pretending that this is an Exynos build, and I just found a different problem. So this is not going to go into my patch set for Apple stuff because it doesn't matter for that, but I will still do it and fix it. So let's see if it builds now, or if that devm thing comes from something else. I think it might already get built anyway. Yeah, we're fine. Or not. It also needs devm, yes, so... If anyone's wondering what that C search thing is, so this is the guy who wrote Google Code Search and left Google, and basically it's like ancient Go code, but it's a reimplementation of the algorithm that Google Code Search used. It's a very simple tool, but basically it indexes source code, and you can search like with regular expressions, and it's super fast. So it's like grep, but instant with regexes. So highly recommended for very simple, like, you know, indexing source trees and stuff. And actually, I alias it to limiting it to the current directory, so automatically it searches wherever I am, and then it just builds a giant index in your home directory, which is what I have here. But very, very convenient. So yeah, talking about that. That's in MFD core. And it probably just needs MFD core. TTY serial kconfig. Yeah. Hmm. That's not what I need. What happened there? Has IOMEM. That's in there. That's in there. I think I just need some of these Samsung something or not. Hold on. I think it's Exynos PMU is what we're going to need. Because this is going for the PMU probe. Wait, hold on, no. That's the problem. Not serial. This is not where we need an FD. Not the serial one. It's this one that needs the. Yeah, I think it works now. Yeah. Yeah. So let's just do. Actually, it should be ARM64, shouldn't it? So I'll split this out into separate patches and send it out separately because it doesn't really matter for me. But okay, so we know it builds, so that's fine. Now the next patch. For the next one, I'm going to split the port types, not add the Apple one. And the Yukon mask is needed for that, not those. And that's going to go away. Yep. Get rid of Apple. Did I just move that to the top? Yeah, that can go later. That's a different thing. That's all different. We don't need that. Don't need that. Just without Apple. And we do need that. And we need the Yukon mask, so that is correct. No Apple here. Case S3C 6400. Okay. Cool. And then the other thing was that we had that if in there, and I kind of don't want to do that. So I think I'm going to change that. So in that case, let's go to... Probably going to use the switch on that one too. Yeah, let's just do a switch here too. Just for consistency. I think everywhere else we were doing that, yeah. Okay. Make sure it builds. Apple's original iPhone used an Exynos chip. That's why. This is all the same driver. Because Apple Silicon has a distant relationship to Samsung Silicon. And in fact, the first Apple Silicon CPUs were still manufactured by Samsung and still partially Samsung chips. We don't actually know if they licensed the Samsung IP core for this or if they just made their own with the same interface. Both are possible. Because they license other IP cores anyway. So, yeah, cool, that builds. So let me just do that here. So. Actually. Cool. Let's triple make sure this builds. Yep. And I think we can mostly do this now, but first I'm going to do the IRQ split separately. I guess that's junk. And that's also junk. Mm-hmm. Ah. Oh, yeah, I'm not even actually compiling this. Hold on, I just realized that's dumb. I forgot to enable that after enabling the sock. That's why. Hold on. So I think it's not getting compiled. probably broke something too. Oh no, it's fine. I'll check that I didn't break anything in the other commits afterwards, but I think we're good. And finally, the Apple things. Oh wait, now. Ah, but we're still good. Okay. And I think everything else is just adding Apple things. Yep, Apple, 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 Apple. This is junk. Apple. Startup, shut down. Apple. Apple, 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 Apple. Yep, Apple. I can use the same commit message for that one. Yeah, the tabs. Cool. And I think we're good. Yep. It's the junk in there. Yeah, we don't need that. Cool. Hold on. And now I can just get rid of that. The compatible should actually go before, so I should be cherry picking that back, but that's fine. And this is... That was just the fix, was it? Yeah. Ooh, what just happened there? Oh, I already have those, sorry. We have the DT bindings and actually, yeah. We have that one. We have that. Apple UARTs. I think that's fine. Yep. And I probably lost my .configs from this. What was this config save? I think that's probably a good one. Oh yeah, that changed. Not 190. Okay. So that, I think, takes care of the first driver that we needed to clean up. And while that's going on, I'm actually going to, you know what, I'm going to clone the kernel a second time because it's getting annoying to have two trees, so... actually, there's a way of doing this with, like, binary directories, but, nah. Nah, whatever. Just wait for a bit. Well, I'm going to check that it builds, though. Well, we can do that later. You can actually do a final check that every single commit in a row doesn't break the build. So while that compiles, that one is fine. And that's just the patch, we're good. And then enable for Arch Apple. I believe I already fixed that in the previously. Okay, so FIQ support, this is going to change a bunch of things. Yeah, we need the selected by Arch Apple. Just gonna go to the toilet for a second while that builds. Okay, so let's see if that didn't break. I might have missed I might have actually missed some kind of config thing. I used that old one, but we'll see if it works. And by the way, the big things of the cleanup in this patch set are going to be that, the Samsung one I just did. Also, the Apple Interrupt Controller driver needs some reworking. And finally, there's a whole bunch of code that, ooh, no working init found. Even though I did pass an init MFS. Probably just or not. Huh. Pretty sure I just forgot something in the config. Really? What did I just break? Is it under MISC? No. Oh, the compression. That's why, the compression. Yeah. That's the difference. Delroth found it just as I was doing it. Where is that message actually? Where does it actually? Oh, here's where it does it. Okay, cool. Would be nice if it had like ANSI colors for the serial log. Kind of hard to tell what's an error and what isn't. Cool. Just to make sure we get the... Yep, that all works. All right. Oh, and the penguin's gone too. I mean, I don't need that, but it looks sad without it. Here. Okay. Anyway, so the FAQ support, the feature is fine, and then this is all... This is going to go away. Yep. So in this case, because I already split up all the patches anyway, I'm going to work on top of this branch for a bit so I can test it easily, and then go back and move the changes out. So, because this change isn't really going to change the arrangement of commits, it's just going to modify ones I already have. So, what I have is... Yeah, the config arch apple thing is going to be done later, so I need to make sure that config arch apple, put that in my to-do list. That all gets moved later anyway. Cool. So here, CPU feature.h. That one. Do I actually use that anywhere? I think everything in here... Why do I have patches in everywhere? Get rid of that. How many patches do I have? Oh, yeah, dot patch. Yeah, those can go away. Don't need any of those. Actually, I wonder if I have to wipe the index to remove files. That'd be annoying. Might have to. That's okay, though. It doesn't take that long. But yeah, no, that's only used in div flags. So I can get rid of that. Completely. And then... And then in CPU type... That's fine, I need that. In CPU feature, though. .c. Sync IRQ to FIQ. This whole thing goes away because we're getting rid of conditionally enabled FIQs. Needs FIQ is fine. Well, we don't need this. And then that went away. Cool. So mine's done. That's done. We went to replies. Yeah. I talked with Mark about this quite a bit. So yep. All right. Now that one's fine. The CPU type's one, so nothing to do there. And then for FIQ support, this is the big one. We're going to get rid of a lot of this code. In fact, we're going to get rid of so much of this code that I'm not even sure if it's worth having this. Well, I know where it has to change, so that's useful. So let's go to include ASM assembler.h, and then we always do that. Dive flags. And I'm going to reorder these so they follow the same order. And then this whole thing goes away. I think that's fine. And then in irqflags.h, important to keep the comments up to date. And then this can go away. This one too. Really just undoing things now. In that case, it's always going to be 3. I think that's fine. And then finally, the kernel entry thing. So we're going to do this as 2 patches, actually. Because Mark sent me a different way of doing this. And I want to keep his name on it, so... Yeah, this is just the whole discussion and all that. That's all that I just then did. Yeah, this patch is going to go in. And this is all... This whole discussion didn't go anywhere. Yeah. Cool. And compat. Excellent. So what we have now is on the FIQ patch, I'm going to undo this whole thing. And this is going to undo everything. Yep. Oh, I thought those were in there, the previous one. Hold on. The CPU feature thing needs to be a separate commit. Yeah, so all this goes away. These will be rebased afterwards. And then FIQs. It doesn't matter again. This is I'm going to be using those as fix up commits for the other ones afterwards. And so now I want to take Mark's code and put it into a separate because this basically works. I think that should apply. Make sure this is clean. Yeah, that works. And there's a little bug in there. That. And other than that, I think we're good for that patch. Basically, the way Mark, I had, because this has to be switched out. So what's going on here is previously Linux did not use FIQs at all. Apple Silicon needs FIQs. So we decided to merge them with interrupts, but only on platforms like this one that need them. So there has to be an alternative thing. And there's this whole mechanism in Linux that is used for patching out things like this. And originally I kept it exactly the same as IRQs, and so I duplicated this vector thing for FIQ with an alternative, but because it's a macro, I had to change the whole macro. And he said, you know what, just do it like this. Have the FIQ vector always be there, and if it's not enabled, then jump to the invalid one, otherwise it gets knocked out, and it just falls through to IRQ, and I'm like, oh, that's clever. Easier to read. So in that case, forget if you could set the author here. You need a git author thing. Yeah, author name, email. Yeah, this. And I asked them if it was okay to do this, so I will just be writing the message, basically. I think I can just sign this off myself. Okay, actually, I should probably just ask him about that. Yeah, I could get rid of the nesting, but that's an extra branch, right? So that adds more overhead, which doesn't necessarily make sense. Just asking him. I'm not entirely sure how that happens. Just the ARM64, I guess. Oh, there is entry. Okay, cool. So we can use that. Once I get a reply, I'll fix the message. But yeah, so now it shows us him, so. It is a pretty readable patch. Cool, that should take care of this. More things, setting that on, macro, yeah, if it compat, that's all good. I don't think anything else happened here. Cool. And then we have the required FAQ support. Okay, so let me make sure this didn't break anything. Actually, did I do that right with the fix? Yeah, I think so. I deleted the changes there, right? Yeah, I did. That's the second interesting thing to be done. After this is just the cake and fig thing. So here's a big one. These two patches are about I/O accesses needing a different mode on Apple Silicon. And this is the big thing that I really wasn't sure what was the right way of fixing this, because I could come up with like 3 or 4 different ways. and it really boils down to, you know, the multiple people that are involved with this stuff, you know, what each one thinks, and if we can come up with some consensus as to how to handle it. And eventually what happened is Rob Herring, who handles the device tree stuff, actually joined our RSC channel, and we had a little talk there, and I think his idea for handling this is quite, like, I don't know, reasonable. Like, and it's not a tiny quick hack, and it's also not sort of, you know, an over-engineered solution. It's a nice middle ground between both of those two, which I think makes a lot of sense. So I'm going to go with that approach. But that means I have to program that. It's actually means writing code. The two patches that I had in here were basically a quick hack and me asking people, okay, this is not the real code we're going to merge, but this is just to make it work. And now let's talk about how we're going to do this. So now we have an answer. So I mean, it could still be that I try this and then, you know, it turns out people don't like it and we have to do something else. But I think it makes a lot of sense for now. So we're going to do that. Okay, cool. That built. There's a good chance this is going to not work if I did something wrong with FIQs, but we'll find out. Cool. That looks good. Excellent. And yeah, so this is the FIQ thing. Excellent, no problems there. All right. So this is all going to go in afterwards anyway, because Arch Apple is going to enable a bunch of different things. And that probably can go at the end. I'm going to be reordering the patches afterwards once this is done. Not bad, we're going pretty fast. I'll deal with that later. Okay, this is going to be a really fun one. So fixmap can go afterwards. So first, this is going to need quite a few patches. So first, I'm going to revert this wholesale because that patch is bullshit. And this is going to get squashed away afterwards. But basically, right now, the point is, if I might as well show you, I guess. Well, it's probably going to require building a million things. Yeah. Okay, so just to show you what happens. So this right now only has the initial patch for making this work for the debug console. So it's going to work for the debug console, and then it's going to stop working once it gets to the real console. Which is good for me, because I want the debug console to work while I debug this code. So, and also the intercontroller is also not going to work. So once we get here, basically the problem is this. When accessing devices, Linux uses this NGNRE mode. Apple Silicon requires NGNRNE, or otherwise it doesn't work. But for PCI devices, it needs NGNRE. And so we can't just change the default, and we can't just... and also that would be a hack. But we need some way of describing that this is required to the kernel, because the kernel needs to be able to run on any device, ARM or Apple or any other ARM device, and so the device tree needs to tell it which mode to use. And that's going to be really annoying. And so the best thing we came up with so far... Oh, someone's asking about the prompt. I'm actually not 100% sure what those are, but I think it has to do with my Python script. Probably just doesn't put the TTY into like raw mode when it prints the messages, and so like something doesn't get interpreted properly. Yeah, you do get errors. You get and you write to NGNRE mapped internal devices, you get asynchronous system error exceptions. And the reason why I didn't know that before is that the first time I ran into this, the serial port wasn't working. So obviously, when the serial port doesn't work, so I can't know that that exceptions don't work. Yeah, see here. Yeah, I actually got it. There you go. So it actually gets the error and panics. And this was happening exactly when the intro controller driver loaded, which is when the first hardware that uses this, because as I said, the debug serial is hacked away to not have this problem right now. So indeed, we get an S error. And this is what you want, because it means that you know when something is going wrong. And yeah, so... sorry, I just got a message. So the first time I ran into this, I didn't know about it because it was the serial port, and I couldn't see the error message. And then I think after that, originally I was using a list of initialization, like some initialization stuff that came from the Corellium kernel preloader, and it turns out there was junk in there that shouldn't have been there. And one of those things was disabling this for some reason. I have no idea why. So yeah, we don't do that anymore in our bootloader, and that way we can quickly know that this is happening. And Mark just said it's fine to... well, I'll do that later. Do you know I'm gonna do that? Yeah, I can do that. I guess I might as well fix these things now. So the CPU feature one gets that, and then the FIQ support gets that, and the IRE map one can just go away. And then that one is Mark's, but I need to reword that to his sign off. Oh, but I might need to... No, it should be fine. Hold on. It should be just... No. Did this get reset? Oh, I guess it does that. Anyway. Huh? Yeah, this. I think we're cool with that. Ooh, what just happened there? The MacMe device tree... Oh, I think I forgot a thing there. Yeah, because it's just empty. So skip that. And then what just happened here? Oh, I think, yeah, I forgot to delete them, didn't I? Yeah, I think we're fine now. Yep. So this is now closer to where we're going to end up in the end. We got the CPU feature first, the CPU types. This is just for docs. This is going to need to be reworded, actually. I'm going to do that now so I don't forget about it. Commit message needs changing here. something like that. So this needs a little bit of review in case there's some special corner case about FIQs on some other special system. I think I saw some ACP thing somewhere, but I think it's quite unlikely that it's going to cause an issue. And just to check that patch. Yeah, so this, like the other patch undid a bunch of things, right? But this is a clean merged version, so basically it's just making, oh, this name needs changing. That's a good point. Should fix that. Yeah. It's just renaming it, but actually, do I want to reword that on ARM64? I think that's fine. Yeah. Cool. So yeah, we call that name LDA. No IRQs also masks FIQs. The error context will also mask FIQs. And masks everything. Yeah, I think a comment makes sense now. Yeah, I think it should be fine. That error context one is used in some ACP thing, but nothing talks about FIQs here, so I think we're probably fine. Yeah. Cool. So on other, someone asks about if no one chose to use FIQs. It's two things. One is that on most systems, there's a supervisor, a trust zone EL2 supervisor, and that uses FIQs. But the other thing is that on systems that don't use that, or where you could use FIQs, it's configurable, but Linux never uses them. And so Linux never had to deal with FIQs because there was no reason to use them, with some exceptions. The Raspberry Pi fork of the kernel uses FIQ as a horrible hack to work around the hideously broken USB controller that those chips have to improve performance. And they might even like some of this code, because it might make them easier to basically all to get FIQs working properly. All they'd have to do is hook it into their RIQ chip driver. But if they were trying to use FIQs to bypass some of the infrastructure to save time, that's not going to help. So I don't know if they can use this code or not, but that's kind of their problem when they want to upstream their FIQ thing. So they haven't yet. So yeah. But other than that, basically, yeah, nobody uses FIQs on Linux. Apple, in their infinite wisdom, decided to hardwire some things to FIQs. And so here we are. Cool. Nothing going on here. And again, let's do a compile check. It should go back to the SR thing. Just make sure it didn't break anything with that. So back to NGNR. So what we need to do is, what we decided to do is the following. we are going to include a property in the bus, which I'm going to call, we might change the name, but that's easy. Non-posted IO. And what that's going to do is it's going to tell the kernel that everything under this bus has to use NGNRNE. Posted, non-posted is PCI terminology, by the way. But because this is going to be a generic feature that basically only ARM64 is going to implement this feature at this point, but a bunch of the code is going to be in common kernel code, so any other architecture could add this. And so I'm using terminology that is not ARM64 specific because this is not ARM64 specific, and because kernel developers are more likely to be familiar with PCI than, ARM64. Device trees and music icon. Good question. I don't know. That must come from my system config somewhere. That's a very good question. Why is there a music icon? It's probably just there's some app that thinks it can open DTS audio. Oh yeah, DTS, of course, right? Because DTS audio. That's why. Yeah, it's just the yeah, because things. Yeah, it would be a raw DTS audio stream, right? Yeah, you know what? I don't actually need that. So how about I actually remove those and try. This actually makes a bit more sense, doesn't it? But the icon though, like, probably makes more sense. I don't know what's used for text files, not LibreOffice, but source or something like that. That's Python. What is that? Source? Nah. Is there a markup thing? Nah, this is your text plane. Where's text plane? Yeah, it's good enough. I'd probably have to restart Kate for that to work, but it's kind of cute. Cool, yeah, we're back to this here. Okay, so yeah, non-posted IO. So what we need here is, first of all, that. Second of all, in io.h, we need a new function called ioremap mp. And E. And then there needs to, because that's over the column limit here. Oh, barely. Cool. So for some of the drivers I'm doing, this is my 100-line marker, 100-character marker, because 100 characters is fine for kernel code, but you don't want to add 100-character lines into existing code that is wrapped at 80. So. So, yep, we add this, and this is the general kernel code. So this is basically saying for any other architecture than ARM64, this just maps to regular ioremap. And actually, this is wrong, actually. Actually, yeah, you know what? This is actually more strict, not less strict than the other one. Cool. So that takes care of that. So now we have the function available. Why is there another version here, though? What's that about? Huh? Why do we have to... Oh, is it just because it gets overwritten? Generic... Oh, okay, config generic IO map. Do we need that? I guess for consistency it makes sense. Even though ARM isn't using this. Do we need this? Because this is not... ARM64 doesn't use this. Let's see if I can get away without doing this. If they want it, they can point it out and then I can fix it. It's just a trivial thing anyway. It means adding a new config option for this, and it's not going to be triggered by anyone, so it's kind of pointless. Cool. So next, the open firmware code needs to know about all of this. Drivers OF. So this is all going to be about address. We need to touch that one eventually too. But basically, this needs a bunch of new code. So it's an IO map. Yeah, in address.c. So this is the tricky bit. Address to resource. Yep. Let's see if I understand how this works. Get address, get parent, and match bus type. Get regular assigned addresses property. And there's a bus get flags. It returns memory for PCI flags. That gets the first cell of the address. So the address of PCI devices are supposed to be, yeah, the flags in the top. For ISA, it looks for the low bit and then those things. Yeah. So I don't think this is where we want to put it. I think we want to have this be a general thing. And then how many times does this get called? It's used in a lot of places. Probably not with flags though, but it makes sense to do it in there, I think. Yeah, it probably makes sense to do it here because there might be some drivers that eventually can get this mapped into something else. So the other question is, the other ugly thing is that this IO resource mem thing is kind of very overloaded. Let me look at struct resource to see if there's anything else we can use in there, but Where is that? PMP maybe? No. Platform device? No, where is that? IO port? Here, IO port. Yeah, it only has start and name flags, disk, and parent sibling child, so it has to go in flags. We're not adding any field to that. And IO resource mem has a single free bit at the top. And by the way, this file is like... this file predates a lot of things. You can trace it to before the kernel used Git, and I think even all these types were already there from the beginning. So the specifics about the way this gets passed through struct resource might... I could see Linus Torvalds going on a rant about this, but that's easy to fix anyway. Most of the code is just going to be the resolving thing, so... Writable, cacheable, range length, type mask, and type is 8-bit and 2-bit. Yeah, those are all taken. Shadowable, extension run, none posted. Actually, how does the beginning stuff work? Oh, wow, is it literally just... Oh, Earlycon already has a hack for that, so that's good to know, but... yeah, all the drivers that need this are using this, aren't they? Yeah. So that's not going to help me. This is a per driver issue. Yep. I don't think it's going to be a particularly good way of doing this. Well, for now, it's going to be like this, and if someone comes up with a better way of doing it, or another option, then we'll deal with that. So, for now... DMA... Oh, yeah, that was one, right? DMA coherent. That is in OS address. The interesting thing is this is kind of what I want, but it's a config option, so it's not going to fly on ARM 64, which... yeah, so this is basically the same thing we need to do here. But instead of a bool, we need an int. Well, no, we're sending a resource flag that is... it can be bool. It can be bool in this case. And then I do need the parent in this case. What's this DMA parent story, though? Sorry, DMA, yeah, but we don't need DMA parent. We need get parent. Yeah, just the get parent is fine. Isn't this a massive bug? It gets the parent and then it does... Wait, is this... do these functions... Maybe it's fine. Do these functions consume a reference and... Hold on. I'm actually not sure this is important to get right, so... Does get parent... Oh no, that's a leak. No, there's definitely a leak because it's not getting... Unless that's doing the right thing, which it might. Actually, is there a function? Oh no, we need to walk everything to get both names anyway. This returns get parent. Yeah, so it either gets the parent or gets that. It's not freeing. It's not doing a put. So that's buggy. This is leaking of references here already. Yeah. And this also just does node while node. The parent definitely does that, right? Yeah, definitely does node get on the parent. This makes all the parent code very awkward, though. Well, that's going to be another bug fix patch for me to add. No, wait, no, the parent gets, but this is gonna... Nah. No, it does put node, okay, so... Yeah, so that's fine. So this is definitely consuming a... Oh no, it does go at the beginning, sorry. It does get at the beginning, yeah, that's fine then. And then it can do a put and get the parent here. And then if not node... Yeah. Let me search somewhere else just make sure that code that is doing this is actually doing the right thing. I get the feeling there's going to be a lot of these leaks. Yeah, I think like nothing. Some of these things do it properly, some of them don't. Is there something at least doing a walk? Oh, here's one that says parent node. Yeah, so this actually puts the parent properly. Yes, this puts the so this is the same thing. This is exactly the kind of yeah. So I'm right that this is wrong. The next DMA parent. Oh, this does actually do a node put, sorry. Hold on. DMA, next parent. This does do a put on NP and returns parent. Okay, sorry. Was that right on here? So this is fine. Yeah, sorry. So this is correct actually. But this one at the bottom isn't then, or is it? Oh, it is, yeah. Okay, so it is doing it. Sorry, this is fine. It's just that I need the OF parent. Okay, so then we're cool. There's no bug. I just need to do that right here. And I don't think this makes any sense. Why? I don't think it really makes any sense to get a node that you're past. It only makes sense for the loop, so that's fine. But in fact, since we want to start with the parent, it should be fine to just do this. Does OF node put work on? Actually, it doesn't make any sense because node is already gone here. So this is dumb. You're not going to put a null node, so that is kind of dumb. I mean, might as well be there, but okay. So this gets a reference. Don't need any of that. Yes, there is a reason to start on the parent because the PCI controller devices are themselves bus devices and have MMIO that needs to be non-posted. So they have to have a posted IO attribute so that PCI devices can inherit that, while they themselves have to inherit the non-posted IO from the parent bus. Well, that's what we're doing. This is an attribute on the bus, but it needs to be recursive because the we can have multiple buses on the way. So I already asked about this on IRC, and we agree that it should be recursive to some extent, or at least stop on ranges. So if there are no ranges, it should return. And we should probably check that. So if there are no ranges, it's not a bus, and then we return false, because that's it. So this makes sense. So if it's not a bus, if the parent is not a bus, then we have no information. If it's otherwise it's a bus, and then if it says non-posted, then it's true. If it says posted, it's false. Otherwise, we keep recursing until we run out of parent nodes, and then we return false. And then the parent will be null at some point, and then we don't need to do anything because then it's gone. So, and that's kind of a pointless put there, but I'm not going to touch that because I don't need to. Cool. And if IO is non-posted, should just say MMIO because. Okay. It's round 4. You know, we can just, this actually makes more sense. We can do the put in there like the top one, but actually make it useful by using break instead of repeating that. Okay, so this is the one. This is the recursion code, and now we need to use this first of all. Where is this declared? Here. So that's the first start. Now for we have this. PCI range to resource, bus ISA flags, OF address to resource. Do I want it in here or do I want it somewhere else? Address to resource, probably in here. What else uses that? Does anything else use that? Oh, for PCI and stuff. PCI uses that. Get PCI address. Yeah, for the translation. And calls that. Oh, but that is a regular function. Hold on. Oh, I see. This is for PCI address resource. And then it gets the bar. Yeah, so you definitely want it in here because it applies to PCI devices too. So it should be in the underscore function. Yeah, so basically... Yeah, that's what I called it, right? Where was that? IO map? No. Here, IO resource mem non-posted. Yeah. Cool. And then here, address resource, IO remap, yeah. There really should be an IO remap resource thing that takes into account the flags and everything. Hold on. Or not. That's kind of sad, actually. Where is this defined? Is it not defined? No, here. IO port.h. There really should be a function for this. Let's see if we can make this a little bit cleaner. Oh, there's another thing here. What do these do? What are these doing? Oh, that's x86 only. Oh, there's a descriptor thing? What is that thing? Hold on. What is that thing? Resource. Where was that? IOport.h? Here. Oh, that. What is that? I just realized. What is this? This is for search stuff. But that's not what we want. First kernel IP tables. Where did those go in again? The thing is, this is all x86 stuff. Yeah, like I'm just realizing that like x86 already has a whole mechanism for something similar to this, but they look them up by parents. Well, let's see what happens for now with the by adding a flag, and if someone has a better idea with the descriptors, we can do that. But the thing is, like, how remap looks that up in yeah. It searches for that. Yeah, so that just walks the whole thing. Is this also x86 specific? No, this actually isn't here. Well, we'll see what happens. Doing it this way for now, and if we have to change this, we will. But at least several people thought this was a good idea. So mostly because otherwise, this would involve probably pulling a lot of code from x86 back into ARM64 or something, like refactoring. I'm not sure if that's a good idea. So let's see what happens. Back to the address H. Yeah, so what I'm pretty sure I want is a IO remap resource thing. That is not in here. There was a divm remap thing going on. Actually, I know the Samsung driver did that, I believe. Where is that? Samsung TTY. IO remap, yeah. Yeah, divm IO remap resource, that should work. So for one, that needs to change to that. I think that calls the OF stuff. Platform device. Yeah, here. Hmm. Oh, here. Ah, there's a whole thing there for the different types. Okay. This one needs changing. Yeah, so this is the OF one. For this one, we need a... Actually, I'm going to make this double wide. Where was I with these? Oh, these are just in here. Okay. Is this used anywhere? Oh, it is. Yeah. Layer map UC. Where's that FM thing? The resource stuff. Keep forgetting what these are. IO port, was it? Yeah. Flags. Honestly, that should probably be kind of just in here. Mm. This is separate exclusive one. IO resource exclusive. If you pass IO resource exclusive, Right. Oh, okay. Strict def mem. Okay, that's a different thing then, yeah. That's not the same thing, yeah. Yeah, so that doesn't, that is, we need a way of doing this without the checking conflicts. So that isn't going to work for OF, but at least these need to exist here anyway, for this to work. So this should be fine. I think it should be fine for Devris. Let's make sure I did that one. Just Linux. Oh, that's a different thing. Ah, here we go. No, hold on. There you see. Yeah. And P. Yeah, so that should be enough for the devm interface, and I think for the serial port, we might be able to get away with that. I should probably have like a map checked though. Where is this one defined? Device.h. I kind of want to. Just something like that. And this is going to be annoying to format. Actually, that's fine. Barely. What did I line previously? Yeah, properly. Yep. And that's not going to work. This code is actually properly... It's at 80 columns. I'm not sure if I think this one's fine. I think that one will fly. For code. This one probably too. Because the neoserv soft limit is 100 lines, so this one makes sense. That one can go like that. Should I call it unchecked or just raw or something like that? It's not really unchecked at this point, because you are checking. It's more like... like no request, but... Yeah, I'm not sure if that's a good name, but we'll see. Names are easy to change after the fact anyway. Yeah, and then in that case, this serial driver can just use... Is this even correct? Does that return null, or does it return something else when it fails? Yeah, it returns error pointer, so that's not even correct. Okay, so we can give that a shot. And going back to open firmware. Where were we? Here. OF address. Yeah, so we do that in address to resource. That should be enough to get it into devm. And OFIO map should just do it here, I guess. Well, no, I can just use devm. Oh, but we don't have device node. Yeah, you don't have a start device, so that's not going to work, is it? Yeah. And it says the same thing here, so... It might work. Yeah. Something like that. Well, let's see what happens. First of all, let's see how much I broke. Because I touched the very core headers, everything's going to get rebuilt. But if this works, I think I'm going to call it a day for today. See how much I touched so far. Not that bad. It's not that horrible a patch. Hey, builds. Not quite. How am I doing that in the ISC? That's a good question. Did I use OFIO map or how do I do it? Yeah, just OFIO map. Mm-hmm. Just to make sure this part of the code is working properly. I did change the flag in the DTS. Oh. And I used the wrong flag in the DTS. Because I changed that, that's why. Didn't even put \n there, so that's gonna look terrible. Hey, that worked. Cool. Okay. So let me do a quick commit. So first of all, we need some of the includes to just add the remap NP thing. Actually, how many io.edges are there in here? I'm actually not sure how the includes for this work. Oh, it does do include arch as in generic IO, yeah. Let's make sure those are actually in there. If anything doesn't include that and doesn't have everything, it's not going to work. What's the one difference? Oh, alpha has 2. Okay, everything is including that. Okay, good. Just making sure this is not going to break everything. Yeah, that's fine then. Hmm. I never understand how Vim does this wrapping thing, where sometimes it wraps and sometimes it doesn't. And like I never know, like, what? Oh, there. I get the feeling we're gonna get yelled at for this change. And this needs to probably get some bindings added to explain this somewhere. I'll do that later. Actually, you know what? The UART code doesn't need this because the UART code, the early con UART code just uses plain IO remap, and this is going to need another hack, but that's another story. So it's actually possible that I don't need this for any of the drivers we care about, but we might. And then the Samsung driver actually just needs to use a remap resource. Mm-hmm. And that would be fixed in the DTS. Yeah, I'll move all these things around later, but basically something like that. And let's just double check that I didn't break anything. Actually, Hmm. Why is it picking up the other branches? Oh, something broke here. What broke here? Does it really need the no reserve one? Oh, there's an input-output error. Huh. Hold on. Someone asking about the keyboard. These are Cherry MX Brown. Is it, oh, hold on. Is it just that I... No, it's in there. Did I do something dumb here? Wait, where'd the apples... No, it isn't here. This 5value art. Yeah, this is fine. Did I do something silly again? No Rick? Yeah. Really? Is that cache info thing? No, it's the same thing. Why am I not getting the errors? So hold on. Serial's the only thing using that. Is it because the serial core already reserves that? No, that doesn't make sense. Oh wait, init port. No, but this is a single port. That should be fine. There's also a... Mhm. Yeah, well, reset port is messing with that, but that's fine. That's weird. The is there thing is definitely correct. That's so weird. It's not failing, but it's not working either. Did I break something in that devim code? Yeah, just adding port and it works. Wait, that's not right. The hell is that? That is not right. Let's see, busy. Is that a 3? No, 16. No, that is the same mem. Huh? Oh, sorry, PA. No, sorry. Those are registers, right? Sorry. That's why. Hold on. Why does it? Okay. Anyway, what was it? KP for printing those pointers? There was a way of making it not do that, and I forgot what it was. That. PX is what it was. So PA is a dereference? Oh, pass by reference. Yeah, interesting. Huh. Yeah, so that works. Oh, wait, hold on. I have an idea. This sets membase. I bet the UART code is adding a reservation for this or something. Map base. Ah, yeah. So this actually, yeah. That's why, because this request mem region is failing. That's why. So it doesn't need the no-rec, because it requested here. Okay, that makes sense then. That's fine. Though really, I think it should be doing the mapping here instead of in the other place, but yeah. Okay, fine. Then we need a no-rec. Okay. Okay. All right, well, let me just double check that this actually works, which it really should. that. And assuming this works, it's going to be all for today. Yep, looks fine. All good. All right, well, that's enough for today, and that was actually kind of the biggest thing. Other than that, it needs a bit of AIC refactoring, and basically we did this. And I need to check to make sure that there's nothing interesting here that I missed, but basically this was decided on IRC anyway, so I think I'm good to say we took care of that one. And that's really most of it. Other than that, I need to do a little bit of AIC refactoring to add a few other things there. And that's pretty much it. So, and just reorder the patches and change some config dependencies. So, see you next time. Maybe tomorrow, maybe next week, or a weekend, we'll see. Thank you for watching. Bye-bye.